Hello everyone. In this lecture, we will determine the wavelength of light. Using plane transmission grating. For this purpose, a spectrometer is required. Actually, this spectrometer consists of three mainly parts. One is known as telescope, collimator, and third, prism table. Three parts of the spectrometer. Spectrometer is the device instrument used to determine the spectrum pattern of white light, the color bands obtained, and their wavelength can be obtained by the formula. We are know that one thing is very important to understand this, the direction of principal maxima. Direction of principal maxima obtained in case of Young slit is given by formula E plus D sin theta is equal to n lambda. Let us see, this is represented by equation number 1. So this formula is used to determine the the main object, that is the wavelength of light. The apparatus required is spectrometer, and second one is grating and source of light. In this source of light, we can select a source which wavelength we are determining. When we use white light with the plane transmission grating, three color bands are formed, so their wavelength can be determined. We can use sodium lamp also to determine the wavelength of sodium light. So according to the object, the source of light is taken here in this case. Now see, wavelength lambda is here. Four term is E plus D, theta angle of diffraction, and order. So to calculate lambda, three terms are required to know. So see, the first thing, that is the determination of grating element E plus D. The E plus D, take before start the experiment, take the grating, and this grating is rectangular, and the formula used in this case is E plus D is equal to 2.54 by number of lines. So it is in centimeter. So on the grating element, see what is the number of lines marked on, written on the grating glass, 15,000, 16,000, or whatever, 25,000 or what. So put that value and determine E plus D, that is the grating element. So grating element is obtained by only the formula, not doing by the experiment. Second thing which is here, for the determination of angle of diffraction theta, then sin theta can be obtained. So it is determination of angle of diffraction theta. So for determination of this, see this diagram carefully. Here in this diagram, let us see, this is a source of light. either monochromatic or white source according to the need. And let it is the ray of light, pencil beam of light is passing through the slit and falls here on the grating, which is kept on the prism table or grating table. This is the rectangular grating, and when this light fall here on a grating, phenomena of diffraction takes place. That is the central bright, followed by color bands, 3 color bands. Since it is started from violet on either side, followed by green light, green color band, and the last one is end red. For first order spectrum, and this white light is here in the middle. This is a white for 0 order principal maximum, n is equal to 0. And with help of here, this is the whole spectrum is analyzed through the telescope. Available here in it device. The telescope is here to use the phenomena. Before to see this, let us see the clear figure of the spectrometer first of all. See here in this spectrometer, this is the grating table. 2 vernier scale are here used to read the reading. Grating glass is mounted here. This wooden box, inside that there is a source and slit is made through it, to which this is the collimator and this side telescope. This collimator, one side there is a convex lens and another side the slit is. The size of slit is adjusted by the screw is also attached with that, and distance between both is kept here equal to the focal length of convex lens here. So what happens when light passes through that, falls on the convex lens, becomes parallel after the refraction passing through the this is. So parallel beam of light is allowed to fall on it is. Adjusted telescope through this is examined. In examine, that is, see carefully here in the diagram in it. In that central maxima, followed by either side the prism, and by rotating this telescope on both sides, and by rotating this telescope, the angle of diffraction for particular color can be obtained, and that position can be read here on the screen like this. Let us see here in this diagram carefully. The angle of diffraction theta can be obtained on both sides. So reading by rotating this telescope and fixing the crosswire here and here, position of both is noted, difference of both. Let first position is theta 1, second position is theta 2, second position is theta 2, and difference is both is called 2 theta. that is obtained position from theta 1 to difference of theta 2. Obtained for a given color, and it is done for all three colors. These three colors are violet, green and red. This and angle for violet, for green and for red is obtained. And this is for first order. So number of order here is case is 1, first order diffraction pattern. So order is 1. For first order, the equation 1 can be written as, see carefully, E plus D sin theta is equal to lambda. So see, theta is obtained by here the experiment, and E plus D is obtained by this formula. So by putting the value here in the formula, wavelength of light can be determined. So this is about the whole topic. Thank you and have a nice day to all.